We are over in, actually I had missed this for a while yet, but we have beautiful layout of what we've been accomplishing here from the optical perspective. And the conversation that we want to have today is really understanding not only what's been released, but how it continues to tell this story of the compounding value. So as we deliver on this platform advantage, a lot of that advantage is actually coming from how we have the optics and the ASICs and that system tied in a way that others can't do, and there's positive benefits to doing that for our customers across multiple aspects, I guess is the right way to say it. But with that, I want to introduce Bill Gartner. I have you come in, sir. Good to see you.
Good to see you. Thank you
We had a little bit of trouble connecting this morning, and I was like,
Yeah.
oh, we need the expert. But give us your title to make sure I don't mess it up.
I'm SVP and GM of the Optical Systems and Optics Business Unit.
So you literally run the business unit that
I run the
oversees
business
this.
unit, yes.
And we've made a lot of changes with acquisitions and continued integration, and this is fun to see. I wonder if you could kind of, as we enter this 1 terabit era, if that's safe to say, but this week's announcements in the G300, can you talk about what's changing with optics and what's been announced? Kick us off in that vein.
Let's start with what's happening inside the data center, which is really what we talked about this week at Cisco Live. Cisco Optics is a full portfolio of optics from 1 gig to 800 gig in various form factors. You can see different form factors that meet different customer applications, different switch or router applications. And we have a full portfolio all the way starting at 1 gig, all the way to 800 gig, supporting different customer architectures and different fiber types. Might be single mode fiber, it might be parallel infrastructure, duplex infrastructure, multi-mode fiber, so we can accommodate any customer's application with our fiber portfolio. And this week, we announced 2 new optics in that portfolio. One is a 1.6 terabit optic, that's this optic here. 1.6 terabit that goes into a 100 terabit switch. It's just magnificent that we're going to have that much capacity coming out of one
It doesn't
optic.
seem twice as big or anything as the others.
No, that's part of the magic, is that we have
it's not linear.
We have to, it's not linear, we have to manage to do that thanks to silicon photonics technology, which is Cisco's silicon photonics. We can actually expand the capacity of these optics without increasing the size. And then we also introduced an 800 gig LPO or linear pluggable optic.
Right here.
And that's an optic that can help customers reduce power. And we can talk more about that as well.
Yeah, because it really starts with one of those advantages you talk about, now I'm forgetting the words, but it's the optical
Linear pluggable optic?
Linear pluggable optics, but we're taking some of the traditional components and we're moving them back into the ASIC. Am I saying that correctly?
Right.
And that allows us to do things in a more streamlined fashion than other competitors perhaps who can only play a part or perhaps are just using off-the-shelf silicon.
So the linear pluggable optic takes the DSP, the digital signal processing function, and moves that function into Silicon One. And in doing that, we reduce the power of the optic by about 50%. So it's very significant power savings. Now we've moved some complexity into the Silicon One. The total switch plus optic power reduction is about 30%. So it's substantial power reduction for customers.
Well, because the thing you always have to remember is we sometimes talk about these in kind of a singular fashion, but then you look at where they're going to go and they're going to be stacked side by side with very little airflow between them and in a very compact factory. And we still have to do something with how that generates, but that's also where you get the scaling.
Super complex. We have to manage the thermal environment here, make sure that all the optics are cooled, make sure that that switch silicon stays cool enough. So these optics can run in either an air-cooled environment or a liquid-cooled environment.
Excellent. Yeah, I've been taking a closer look at also how we're doing direct-to-chip cooling now and new platforms. That's very exciting. Well, I'm curious, so how is AI traffic in the data center really changed how we've traditionally, seems like a server could go up or down or be bursty, no big deal, we'll resend packets. We're still doing this on Ethernet. It feels like we've really beat out InfiniBand and that consistency is going to remain. How are we dealing with that from the optical perspective?
Yeah, so one of the insights that we've obtained in looking at AI infrastructure versus a classical network infrastructure, exactly what you said. In a classical network infrastructure, if there's an error burst on a link, TCP/IP bridges that. You never really see that as an end user. There may be a retransmission of the packets, but there's no impact to the end user traffic. And there's no impact to neighboring links as well. in a GPU infrastructure, you've got all these GPUs operating in parallel, and so if there's an error on one of those links, all of those links have to stop, back up, and then restart. So those GPUs become very inefficient when they have to stop, back up, and restart. So the impact of a link error on one link in a GPU infrastructure is much greater than the impact in a classic network application.
And these GPUs are obviously super expensive.
You've got
Everything's
these,
starting up, so this adds up quickly when these kind of mistakes happen.
very expensive GPUs sitting idle,
Ooh,
and that's just a
that
bad
is
thing.
Yeah.
Meta actually did some analysis and concluded that you could see a 40% reduction in the overall efficiency of that GPU infrastructure because of this effect. So what we do is, number one, we rely on silicon photonics, which is inherently very reliable because it's effectively an ASIC. And number two, we put our optics through a qualification process that is really the gold standard in the industry. We qualify our optics against all optical specs, electrical specs, environmental specs, and we do corner case testing. So we test the optic against the worst case temperature, the worst case voltage, the worst case host environment. And in doing that, we know that our optics are really the best that could possibly be delivered to our customers. We know that because we've acquired optics from the suppliers in the industry, and we put those optics through our qualification. And in one test where we acquired 35 different optics, none of those optics passed our qualification test. So we feel very good about the quality of Cisco optics going to our customers.
Well, I like that because some people may not understand, and make sure I'm understanding it correctly, is that Cisco owns that whole part of the process, and of course, this is where we can bring these advantages to customers. And make sure I'm saying this correctly, but one of the advantages of reducing power at this level by this much amount, even if you're not a hyperscaler and you're not doing the 1.2 to 4, whatever terabits, the idea is that a lot of our customers, if they're going to be doing any kind of AI in existing data center space, they're going to be power and space constrained. This begins to free up some real estate so that they could potentially look at reconfiguring and taking advantage of it.
Yeah, I mean, one way to think about it is every watt we save here goes into GPUs for our customers. So even a nominal power savings is very important for our customers.
Bill, this is fascinating. I appreciate you taking the time to meet with us this morning. Guys, I encourage you to come by and take a look at these things. They have the every generation of the switches, the ASICs, if you will, and then you can walk through and kind of see how they're all working together and ask the story of all the smart people that are here.